Hello everyone, my name is Furkan Karademir. This is my PHYS102 project. My project's name is Magnetic Flux Change and Induced Electromotive Force on Copper Coil. The purpose of this experiment is to study the application of Faraday's law in the real life and how the parameters like loop count and loop area of copper coil affects the induced electromotive force on coil. Now let's look at the background of my project to understand my experiment. Magnets are the objects that exert attraction or repulsion force on the similar kind of materials. The field giving magnets the ability of attraction or repulsion is called magnetic field, and magnetic flux is the number of magnetic field lines passing through a surface area. So magnetic flux can be found by taking the integral of B dot dA. B is the magnetic field and dA is the surface vector. If the angle between surface vector and the magnetic field lines is alpha, magnetic flux can be represented by B times A times cosine alpha. Faraday's law is what established the connection between magnetic flux and induced electromotive force. He discovers that the change in magnetic flux on a loop results in a current, which is electromotive force. So, induced electromotive force for a coil is the loop count times time derivative of magnetic flux. The equipment I use for my experiment is the following: magnet, multimeter, copper coils, ruler, and a tripod. Before experiment, I prepared 4 copper coils with different loop areas and 4 copper coils with different loop counts. And then I put an insulator between tripod and my magnet to prevent the effects of external factors on my experiment. Here I release magnet for different loop areas. For each area I repeat the releases and take the average of electromotive force to get a perfect result. Then I release magnet for different loop counts. For each loop count I again repeat the releases and take the average of electromotive force as in part 1. And I recorded all the data on my tables. These are the data and results I measured. So we learned that electromotive force is directly proportional to loop count and loop areas as seen in the plots. In the end, using the magnetic field value of magnet and Faraday's law, I calculated the theoretical values of electromotive force for different loop counts. And then I calculated the errors between measured values and theoretical values and found the average error in my experiment. As a result, the average error is 10.4%, which is almost perfect, but it requires some explanation for its sources. The first reason is that even though I put an insulator to eradicate external factors, it has still small effects on my results. The second reason is that the multimeter has some small error percentage. Another reason is that I choose loop count as 15, 30, 45 and 60, which are easy to rep, but getting perfect results from such small values is very hard. Another reason is that the magnet is used hundreds of times by other people and it doesn't have the magnetic field power anymore as indicated on it. Lastly, nothing is in perfect condition in real life and even small human mistakes and environmental conditions causes errors. In conclusion, these experiments make me dive into the magnetism topic and learn how to overcome the problems arising in the process of experiment, which is very helpful. Thanks for watching.